This first one, this is part of a free response problem. This would be on a non-calculator section, and it's just one part. I'm not gonna throw you guys an entire AP problem just because if we were only doing part A, if you were looking at parts B, C, and D, it might just really freak you out that it's something that makes no sense to you yet because we have barely put a dent in our content for this year. So if we read through, we've got a 12,000 liter tank of water filled to capacity, and what's happening is the water is draining out of the tank. And so this is the rate at which it's draining. So each one of those are measured in liters per hour. First part is given by a rational function. Second part is given by an exponential function. So piecewise means you've got two different domains going on, or three different, or four different, however many pieces your piecewise function has. So the first piece says that if you're starting at 0 hours, like whenever it begins to drain, and then ending at 5 hours, that rational function is giving a model for how quickly the water is draining, and then starting at 5, it switches. So I know you guys have seen piecewise functions. It's usually not a huge topic that people are super comfortable with. So you guys will have exposure to these. And it's a really good topic that you can work with continuity because it's kind of a natural like left and right sort of limit that you can check because you've got different functions coming in from the left and from the right. So part A asks, is R continuous at t equals 5? First thing I want you guys to pay attention to with these AP problems, please make sure when you give your final answer that you're actually answering the question that was asked. So when the question is R continuous at t equals 5, what should you have in your answer? Yes or no. So you need to make sure you're actually answering it, and then you'll have work, and I'll explain what work needs to be shown for this one. So is R continuous? So up on the board, and you guys have this on your notes too, up on the board on that second chalkboard, I've got the 3-part definition of what it means to be continuous. The really, really easy definition that I can give you is that you don't lift your pencil. If you were drawing the graph, you wouldn't lift your pencil. And this kind of fills in the gaps here. So point number 1, the limit at that point exists. So if we're talking about this one, we would need to know if the limit of the function at t equals 5 exists. Second condition is that the function value has to exist. So the function would need to exist at t equals 5. And then the third part is actually the most important part because it kind of ties it all together. Not only does the limit exist, not only does the function value exist, but those two numbers are equal to each other. Because it is possible that the third condition isn't met, even if the limit exists and even if the function value exists, they might be different values. So it wouldn't be continuous. So that's our 3-part continuity definition. Anytime on the AP test or on one of my tests, if you're asked if something is continuous, you start to define that 3-part definition. So you check point number 1, check point number 2, check point number 3. If at any point the condition is not held, you can just stop. Because if the first condition isn't held, there's no point in going any further because all 3 of them need to be held. So we'll start with condition number 1 to see if the limit exists. So we're dealing with the piecewise function. So since it's 2 separate pieces, make sure you guys are checking left limit and right limit separate from each other to make sure that they match up. So we're gonna test the limit as t approaches 5 from the left of R of t, and then we're gonna check the limit as t approaches 5 from the right of R of t. Okay, and we're gonna do kind of a plug and chug and see what happens. So as we approach 5 from the left, that's 4.9, 4.99, etc. Look at my piecewise function. If I'm plugging in 4.9 repeating, where am I plugging in that 4.9 repeating? In which one? From the left, so which piece would I be using if I'm approaching 5 from the left? The top one, good. So look at the domains, guys. This one goes from 0 to 5, including 0 and including 5. So if I was plugging in 4.999, that would fall into this domain, not this domain. Okay, so if I'm plugging in from the left to 5, I'd be plugging in to the first one. Okay, so if we plug in something really, really, really close to 5, let's plug this in. Plug in something really, really close to 5 into the numerator. You can just plug in 5, it's fine. Oh, I should not hear any calculators. 600 times 5. You can handle this. 3,000. Good. Do 6 times 5. Throw those zeros on there. Super easy. So the numerator is going to be really, really close to 3,000. And the denominator is going to be really, really close to 8. Good. Now, this is a non-calculator section. So if you just want to leave 3,000 over 8, they don't care if your answers are unreduced. because they're testing calculus, not like arithmetic. So if you want to actually go out and do long division, that's fine. If you don't feel confident in your ability to divide this, that's fine as well. You can just leave it. Okay. Second part, 5 from the right means 5.1, 5.01, etc. Which domain would those numbers belong to? The bottom one, good. That would be t is greater than 5. Even just slightly, these numbers that we're talking about are still greater than 5, so that would go into this one. So plug in, and you can just plug in 5, just like I did here. This one doesn't have any issues with plugging in 5 into a denominator or anything like that. So if I plug in 5 here, I have 1,000 e to the, and then really, really close to 5 would make that power really, really close to what?
1.
Careful. -1, good. So that is like 1,000 over e. Okay, keep in mind we don't have a calculator. Tell me, are those values equal or not equal? Probably not equal. Let's think logically. Why are those values probably not equal? Yes, sir. They're totally different functions. Yes, so that's kind of along the lines where we want to be. They're totally different types of numbers. What type of number is e? It's the same type of number as like pi or like the square root of 2, you know, numbers like that. Yeah.
It's an imaginary.
Not imaginary. Close. Irrational. Good. 1,000 divided by e is an irrational number. What kind of number is 3,000 divided by 8? Rational. Good. We've got a rational number versus an irrational number. You don't need your calculator to know that that can't possibly come out to be equal. They're pretty close, but it doesn't matter if they're pretty close. They have to be exactly identical to each other in order for that limit to be the same. So close, unfortunately, does not cut it here. So our answer would be no, because it says is r continuous. So our answer would be no. And how would we explain that? How would we say that no, it's not continuous? What do you think?
The values of the two limits are not exactly the same.
Yeah, they're not exactly the same, which means the limit doesn't exist. And so you could say that the limit as t approaches 5 from the left is not equal to the limit as t approaches 5 from the right. We're running out of space, so just bear with me here. So no, the left limit is not equal to the right limit, so therefore, what can I say about the limit? Good.
Do you have to write the part about the left limit doesn't equal the right limit?
You could just do that kind of conclusion statement because you've got the work in front of you that's showing that they're not equal. Or you could just say like 3,000 over 8 does not equal 1,000 over e, so the limit does not exist. There's a certain point, and we're going to have so much practice with these AP problems before May that you'll know what's too much and what's not enough. It would not be enough to just say no and, you know, put nothing behind it. It would be too much to say, no, the left limit is equal to this, and the right limit is equal to this, and they have to be exactly equal, but they're not, and that means they're not the same, and that means the limit doesn't exist, and there's a 3-part definition of continuity, and the first one is broken. Like, that's too much. So the more that we do these problems, you guys will figure out that precision of saying exactly enough, making sure you have enough of an explanation without going overboard, because these AP readers are not going to read 2 paragraphs of explanation behind like one little part of a problem. So that's all you need for that one. Questions on that? So 3-part definition of continuity. If one of the points is broken, you can just automatically stop. Because if one of those conditions isn't met, there's no point in going any further because all 3 of them have to be met. Okay. We've got 2 more multiple choice questions. We've got one that's labeled as a number 5, and then there's a number 9 from a different test on the back of this page or on the next page. So I'm going to give you guys, probably won't need much more than like 5 or 6 minutes for you guys to work on these within your groups. So work on these 2 multiple choice questions. Let's go to like 11:17, and then I'll start going over them with you guys.